This is CryptPad. It's a real-time visual, that is WYSIWYG, what you see, what you get, editor and it's collaborative in the way that Google Docs is collaborative. And what sets it apart from other editors is that the server is not able to see what you are typing. So if somebody owns the server, usually like with any kind of activism, journalism kind of stuff, the single point that is most interesting is the server. You want to get access to the server, and then you can just listen to what everybody's saying. But with this kind of thing, you have to attack at each computer individually. It's very difficult. And this design, this is based on a project called ChainPad, which started with this question that we asked about a year ago, how can we make real-time in XWiki? And it turns out that real-time is kind of crap. It's the standard that everybody uses for real-time. It's called operational transform. It started with Jupyter. Google did major improvements on it. It's a very complex protocol. And it is very difficult to get it to do well with it because the complexity grows cumulatively. That means if you want to do bold and text, if you want to do just text, that's okay, it's easy. That's, you know, share.js and these kinds of things that was just collaborating on plain text. If you want to do bold, then you have to say, well, what if one person makes it bold and another person types text in this kind of the same place? How do you resolve that? And if you want to do italic, then you got to resolve bold italic, bold text, italic text. And then if you want to add color, then you have to resolve all four. And if you want to add like bullet points or paragraphs, you have to resolve 8. And so this complexity explodes as you increase the number of things that you want to be able to do. And that's why when you look at one of these real-time editors, usually they have very few buttons because every button that you add is more difficult, more complex than all the buttons before it. This stuff is really not portable. And that was one of our big problems because we're Java. And if we developed something here, it would not be able to be used in PHP. It would not be able to be used for Node.js. And basically, we would be stuck using GWT. That's the Google project to compile Java into JavaScript. Because when you're using operational transform, what runs on the client in the browser has to be the exact same really complex project that runs on the server. So that each thing is a multiple of everything that came before it. That algorithm has to be done twice. It has to be done in the browser, has to be done on the server. So if you're in Node.js, fine, it's JavaScript. If you're using Java and GWT, that's okay. You compile from Java to JavaScript. If you want to do this with anything else, you're screwed. So it's very, very unportable, and that creates a lot of problems. And especially for open source, because if we're doing open source, we need to be able to approach like Drupal and WordPress and Joomla and everybody who is in all different kinds of programming languages, Django, whatever. And yeah, a lot of calculation happens on the server. So this doesn't seem like it would be that complicated, but it turns out that the server does a lot of number crunching, and when you start to scale that, you need a lot of server horsepower, which if you're Google and your Google Docs, you're like, yeah, okay, fine, we'll put a data center on that. But that it's difficult, it creates a scaling problem, and all the power that's in the browser is not being used for what it could be. So this ChainPad idea about a year ago came from this thinking that we would create something that we were going to clean room the idea, start from scratch, create something that that had no server work nothing happening on the server to speak of. The server would just be sending messages between the client. We could even imagine removing the server. So we kept everything in the browser. That way we got portability, because the server, yeah, it's written in Java, but fine, it's 150 lines of code. Yeah, you can rewrite it in anything you want. And now this, obviously, it's a hard problem to achieve consensus between browsers without any server to tell them what the truth is. And that's where the solution is the Nakamoto blockchain. Basically, ChainPad is Bitcoin without the proof of work. It's just proof of work is stubbed out, and if the ChainPad clients find consensus the same way that Bitcoin clients do, so it has the same properties as far as peer-to-peer ability to bolt peer-to-peer onto ChainPad and eliminate the server entirely. Would be basically you would just build the lower half of Bitcoin onto the client in the browser. So Etherpad is one of the well-known collaborative editors. Operational transform, which is carried out in the browser, which makes the changes. So this is a little bit low level, but basically when you and I are both typing in kind of the same place, somebody's text has to be kind of moved or altered in order to make sense in the context of the other change that happened at the same time in the other person's computer. So when they're transformed, traditional Etherpad, Google Docs, these things do the transform on the server, and they say, here is the new truth. With ChainPad, you transform your own change. So you get a message in that says, no, your change is no good because this other change came first, and then you will transform your change and send it again, saying, okay, now I transformed it. The advantage of that is that the browser of the person who created that change knows best how to alter it. And because we're so close to the DOM, because we're right in the browser, we can actually carry out operational transform directly over HTML, just treating it as text, which is pretty awesome because now it works with any editor. It works with anything that is markup-y. We can do operational transform on it. No more of this every time you add a button, you need to write a bunch of code stuff. And yeah, obviously very little server code. And this was for getting real-time into XWiki. It's been an ongoing project. It's definitely a hard problem. But one day, 2 days of furious hacking, and I just was feeling like I wanted to build something. So I wrote CryptPad. And it's taking ChainPad and encrypting the messages so that the server can't read what you're typing. And you put the key into the hash and the URL. So you see there's like website / and then there's the hash, the anchor. That anchor is never sent to the server. That's just a quirk of the HTTP standard. And we use that in order to put the key in the anchor. And so the key is part of the URL. It never goes to the server. The server doesn't know. The server doesn't want to know. If it wants to know, it can do evil things like send you bad JavaScript, but that's a different story. The server that doesn't want to know then is able to transmit these encrypted messages, and anybody who has this URL has authorization to access this information. And in this 2 days, I ported the server-side code from Java to Node.js. It was quite trivial. And I ported the storage into MongoDB to try that out. I ported the client from XWiki's WYSIWYG editor, which XWiki WYSIWYG does have this ChainPad, but not encrypted. And I ported it to CK editor, and I built CryptPad. And This is running now. You can go to CryptPad.fr, and that's not actually a good URL. CryptPad.fr hash SeaBeyond1. I'll just put that in the pad. And what's interesting is I've got the WebSocket here. This uses WebSocket. And if you look at this, the content that's going over the WebSocket, I don't know how well you can see that, but that's not something that the server can really see. There's the server, that's all encrypted. The key is this SeaBeyond1, hash SeaBeyond1. It's not a very secure key, but if you just go to CryptPad.fr with nothing, it will redirect you to one with a really secure key, a big, I think it's 120 bits, something like that. So I'll just leave that there. So what else can we do? Collaborative drawing. I'd really like to try this on SVG. There are SVG editors in the browser. It's DOM, it's XML, why not? I want to know how far we can push this idea of synchronizing DOMs of browsers. Get rid of the server, which I used to not think it was that exciting because, yeah, a server that knows nothing, what does it matter? But actually, it can be exciting because maybe you don't have internet. Maybe you're at a protest and you want to have like a pad while you're at this protest, but the only thing that you have is everybody who's there who has Wi-Fi. So if you can communicate via a WebRTC and you have no server, then that could be really interesting. And this is kind of like just a beginning, I think. And the question that I want people to take away from this is, what kind of tools can we create? What kind of tools should we be creating to make the world a better place, to make it a place where people can do collaborative dissent? Because right now, what I hear a lot of is that people who have money, they get things are being catered toward them. And what the people who are not getting something catered toward them are the people who are really changing things. And you know, if everything you do is for the 1%, then the 1% is just going to control everything. If the 99% never get tools to become not the 99%, then we're never going to get out of this mess. Thank you.